Good afternoon. So this is my exposure. So I will speak about the functional data. So my topics is some asymptotic property of the conditions indexed to empirical processes based on dependent functional data. So with the joint work with Salim Bia, Professor Salim Bouzbda and Professor Madani Fathi. So my outline is introduction, model and assumptions, results and conclusion and bibliography. So our models and assumptions. We consider samples of random elements x1, y1, copies of xy that takes values in ERD. The functional E is equipped with the semi-metric DE. D is the metric which allow the distance between x1 x2 equals 0. Sum for sum x1 depends on x2. We aim to study the link between x and y by estimating the functional operator associated to the conditional distribution of y given x such the regression operator for some measurable c in the class of sets defined by this formula. The regression relationship suggests to consider the following in the area Watson conditional empirical processes defined by this phrase. The key is a kernel and the B is the small ball and the ft is the small ball probability function when t is decreasing sequence to a 0. So our model is defined by this formulate. Our mixing is defined by this formulate. True to the cycle, we assume tactically the sequence R of random element x, y is strongly mixed. We through do this work is fixed element of the functional space E. We define the metric entropy inclusion, provide the measurability of richness of the class C for each to the covering number is defined by the formula. So we need this function of the Lipschitzian of the regression. So the third assumption is satisfy the finish of the expectations. The third hypothesis is the continuity of the distribution functions, and the five assumptions is the Lipschitzian of the density functions. 6 is about the kernel. 7 assume the class C satisfy the condition 3. 8 is the mixing satisfy this formula. So the smoothing parameter satisfy this formula. It consists to a 0. So our main result is the uniform consistency. Suppose that the hypothesis H1 H8 hold and that xt yt is geometrically strong mixing. So we get the soup of our processes consists to 0 in the probability. So to prove our result we need this decomposition where the distribution function defined by this formula and the density function defined by this formula. So our lemma, the first lemma is the distribution functions consist to 0 in the probability and the density consists to 0 in the and the asymptotic the second theorem is the asymptotic normality. So we prove that our estimator consists to a normality law with the mean equal 0 and the variance equal to this quantity. Third theorem suppose that H9 hold is exponentially strong mixing for each measurable sets with these functions. We prove that the soup of our estimator is strict of our discrete. We prove our result to make hypothesis. This is our hypothesis. We prove that our estimator consists to this quantity and the second estimator consists to this quantity. our beliefs, and thank you.